Now let us calculate how much a voltage drop will be in a 1 meter wire length. So generally we know that a wire length of 1 meter will have a inductance of 1 microhenry. Now general calculation for potential difference will be, for first positive impulse we knew that di by dt was 20 kiloamperes per microsecond. V is equal to L di by dt. We all know that. So L is 1 microhenry, which we have written earlier. Di by dt is 20 kA per microsecond. So there will be a potential drop of 20 kV per meter in case of first positive impulse with a wire length of only 1 meter. Similarly, if we calculate for first negative discharge of first negative impulse and subsequent impulse, V is equal to L di by dt. L is 1 microhenry. Di by dt in case of negative impulse was 100 kA per microsecond. Di by dt in case of subsequent impulse was 200 kA per microsecond. So voltage drop comes around 100 kV per meter and 200 kV per meter. That means whatever good quality SPD we are using, with 1 meter of wire, the voltage protection level or the voltage drop will be around 100 kV per meter. So now what standard says about this? So standard first talk about the residual voltage to equipment. That means the effective voltage protection level in an equipment will be the voltage drop across, I will explain in this way, the voltage drop across wire plus the voltage protection level of an SPD plus the voltage drop across the wire. This I am going to explain in the next slide. So as per IS 732 and NBC 2016, the maximum acceptable wire length across SPD is 0.5 meter. That means if you see a connection, this is your main breaker and this is SPD connected in between earth and this line. Let's say it's a line. So from line to SPD, there will be one wire. From SPD to earth bus bar, there will be a second wire. Let's imagine length of first wire from main incomer to SPD is A meters. From SPD to earth bus bar is B meters. So standard says that A plus B shall not be more than half meter. I am repeating again. Standard says that A plus B shall not be more than half meter. That means total connecting wire of an SPD, including the connection between line and SPD and earth, should not be more than 0.5 meter. So there are basically two type of SPD connection. First one on the left side. Second one is a bus bar mounted connection, which is on the right side. Same is explained very well in IS 732 as well as NBC 2016. So what we have concluded is long connecting wires will have lesser protection. Now, selection of SPDs on the basis of voltage protection level and how voltage protection level is dependent on the wire length. Now, there are three parameters: UW, UP, and UPF. UW is voltage impulse withstand of an equipment. Let's say I am talking about an UPS. So every equipment has a certain voltage with impulse withstand capacity. It can be 1.5 kV, 2 kV, 3 kV, or it can be anything. But they will mention this UW in their data sheets and parameters. Second thing is UP. UP is the voltage protection level of an SPD. That means it is the level at which SPD starts operating. Now, UP can also be said that considered as a voltage drop across the SPD. Now, third parameter is UPF, the effective voltage protection level. That means after considering all the voltage drop across wire, SPD, and the another connecting wire, the resultant voltage protection level is called as effective voltage protection level. Now, to ensure the equipment safety, the condition which we need to fulfill is UW shall be higher than UPF. That means impulse withstand voltage of an equipment shall be more than the effective voltage protection level of that SPD. Then only that SPD is going to protect our equipment. So let's see, this is an SPD connected in between point A and B, and D is an backup protection or disconnector fuse. You see, L1 is the wire length 1. Then there's a voltage protection level of UP is the voltage protection level of SPD. Then L2. Now, effective voltage protection level or UPF will be voltage drop across L1 plus UP plus voltage drop across L2. So if we go as per standard IS 732 and IC 61643, we have considered a wire length of 500 mm. And let us calculate the effective voltage protection level. So voltage drop across 500 wire length, wire length, in case of first positive impulse will be 10 kV. As we have earlier seen that 20 kV was for 1 meter of wire length. So for half meter of wire length, voltage drop will be 10 kV. First negative impulse will have a voltage drop of 50 kV. We have seen that for 1 meter it was 100 kV. So for half meter it is 50 kV. For subsequent impulses, for 1 meter it was 200 kV. So for half meter of wire length, which is the standard recommendation by the standard, it is 100 kV. Now we are going to see the calculated UPF. Calculated UPF will be UL1, which is 10 kV. Sorry, UL1 plus UL2 is 10 kV. And then UP is 1.5 kV for general SPDs. This can vary SPD to SPD, but generally it is 1.5 kV only. We have considered 1.5 for that reason only. So for first positive impulse, the calculated UPF, the actual voltage protection level of the SPD is 11.5 kV. For first negative impulse or discharge, it is around 51.5 kV. And for subsequent impulses, it is around 100 and 1.5 kV. So is our system actually protected by this? And now, what is the solution? We are going to talk about that particular thing in this webinar. And again, these values are calculated from level 1, LPL level 1. We have also made a calculation as per level LPL level 4, which also I am going to show. So let us consider a wire length of 500 mm, and we have considered 50% current in LPL 4. So, one second, just a moment. So we have seen that in LPL 4, first positive impulse was having di by dt of 20 kV and current of 100 amperes. So we have calculated first positive impulse will have a voltage drop of 2.5 kV. First negative impulse will have an impulse of a voltage drop of 12.5 kV. A subsequent impulse will have an impulse of 25 kV. So effective voltage protection level, effective UPF will be for first positive impulse, it will be 4 kV. First negative discharge, it will be 14 kV. First subsequent impulse, it will be 26.5 kV, which again is very high. So now we know that with increase of wire length, we are going to have a very high UPF, and we have to reduce that as less as possible, as low as possible. The best case scenario is if we have a wire length of 0 meter. If we have a wire length of 0 meter, the calculated UPF for first positive will be 1.5 kV. First negative will be 1.5 kV. First subsequent impulse will also be 1.5 kV. Because of this 0 wire length, there won't be any voltage drop.